So I am Porter Libby, and today I'm talking about my version 0.1 of my Senior Capstone project. So this diagram is from 388, and I've mostly stuck to this plan with a few changes. For one thing, the GUI is more on the back burner than it originally was. I may still implement it, but it's not the priority of the project, so I've kind of left it out for now. So far, I've mostly focused on these first three green blocks: pre-processing, edge detection, and machine learning. The pre-processing and edge detection sections are mostly what's done in my current version of the project. So this diagram goes over what I'll be demonstrating today, which is really just the first few steps of the pipeline from this diagram here. So in my demonstration today, I'll have a folder of input images, and input images for an AI in this case would be a parent folder with a subfolder of positive examples and a subfolder of negative examples. And this input folder could be anywhere as long as you can pass the path to it into the prepare database function. Prepare database will take these input images and create the same folder structure as in parent folder, and then a folder of positive and a folder of negative examples. These processed images will have three different edge operations or algorithms applied to them, and then each of these edge detections as a black and white image will be compressed back into a single JPEG, with each image detection of the three layers acting as a different color channel in that JPEG image. And I'll show an example of that in a minute. And then these pre-processed images that have been compressed will be passed to create model from path, which is a function I've written that creates a ResNet model using this folder structure, and it will train it over the images in the input path. And the input path in this case will be our processed images, the duplications of the input images that have been edge detected three different ways and then compressed back into a single JPEG. Okay, so for reference, here's what my sample training set looks like. It's called EC Small, and it has two subfolders, which are features and no features. It's a simple binary classifier. In features, you find images which are images which contain underground features that we want to detect. You can kind of see them along here. And if I go back to the no features folder, these are similar images that do not have detectable underground features. And the images that I'm using today came from the Wayne County Beacon website, which provides some pretty recent GIS data of campus, some pretty good high-resolution photos. So for my positive case, I'm using the structure in front of CST on the front lawn, and for my negative case, I'm using the opposite side lawn in front of LBC, where nothing has been built. Alright, so here's my demo, and for the sake of this example, I've put the stats for the computer running this code in the corner. It's a different computer than what I'm recording on. So yeah, first I'm going to load up all the imports, and then run all the functions that I'll be using. I'm not going to go into a lot of detail on these because some of them are complicated, and I could spend 4 minutes on each of them, really. Alright, so process database. It runs all of these. So you can see for each set under features, it created 4 composite images, and then under no features, we get 4 composite images. These images go into the out folder here. You can see it looks just the same as the EC training set folder, but these images are compressed versions of 3 different edge detections. So as you can see, I get a heavy variance in training loss, and valid loss pretty consistently went down. Accuracy stayed the same, But these things are really to be expected since I'm just using a sample set right now that only has 8 images. So that's my demo 1.